very good. Overall luminescence degradation, limited market availability. Of course, these OLEDs not much available in the market, also very less. Applications, they are used in television screens, computer displays, portable system screens, advertising, information and indication. It can be used in a light source of general space illumination and large area light emitted elements. And the applications are almost similar. LEDs will use in displays in computers. OLEDs will we can use in the same. Only it is advanced. So it is very easy to write in exam point of view. Applications are similar. Of course, sometimes same also. Here also nothing to worry. If you want to think about the exam point of view, let me tell you in simple way. Here also principle is the same. Just write the what is the principle, draw the one diagram and explain what are the parts. There is the construction. So working, it's very simple. If you apply the voltage, the recombination takes place. This is a simple working. It's common working phenomena. So then advantage, the applications you can write. Fine. Similarly, next polymer light emitting diodes, PLEDs. This is one more advanced LED. PLED is a polymer that emits light when voltage is applied to it. The structure comprises a thin film semiconducting polymer sandwiched between two electrodes, namely electron cathode, as shown in figure. As we see in the figure, here semiconducting polymer layer we will place in between the electrodes. That's only the difference. Semiconducting polymer will be sandwiched between the electrodes. When the electrons and holes are injected from the electrodes, the recombination of these charge carriers takes place, which leads to emission of light that escapes through the glass tube. That's a common phenomenon. The wavelength of this light depends on the band gap of the polymer we use. Which type of polymer we use, based on that the light will be emitted. The emitted light wavelength performance will be depends upon the which type of polymer we use in between the electrodes. This is the basic principle. Construction, similar we see the diagram here, one by one layer. What are the layers we can see here? Initially substrate and that anode, and that whole transport layer, the primary layer, emissive layer, cathode. These are the different layers. Simply in exam point of view, if you draw the diagram, what are the parts here? Just note down those, then explain that. That is called construction. Nothing to worry. Working, here also almost similar. The electrical current flows from the cathode to the anode through the organic layer, giving electrons to emissive layer and removing electrons to the conductor layer. This is the thing. These removing electrons from the conductor layer leaves hole that need to be filled with the electron in the emissive layer. The holes jumps to the emissive layer and recombine with the electrons as the electron drop into the holes. Then they release their extra energy as light. It's a little change only compared to previous LED. Process similar, but little changes. That only, the difference only we have to understand. Similarly, advantages you can write. It's require only 3.3 volts and have lifetime more than 30,000 hours. low power consumption, self-luminescence. Like that, so many advantages. Here we can see I listed 13 advantages. No need to write all these 13, just if you write 5 advantages, enough in examination. Disadvantages. There are few disadvantages. Vulnerable to shorts due to contamination of substrate surface by dust. That is one problem. Voltage drops, mechanical fragile, potential not yet realized. These are the few disadvantages. Applications in photovoltaics. Polymer semiconductor used to develop the efficient solar cells. Photovoltaics means nothing but the solar cells and light detectors. In solar cells, most probably this type of LEDs we use. And also MP3 display players use this type of LEDs. Like that, there are so many applications you can see. These are all the about LEDs. There are 3 types of LEDs. One is normal LED, second one OLED, third one PLED. These are the 3 types of LEDs. Most important question in examination. Next topic, plasma display devices. Plasma displays, you know very well. This plasma display generally consists of 2 glass plates. You can see here in diagram. A gas discharge plasma is created by applying the electrical field between these electrodes as shown in figure. Here we can see 2 electrodes. In between we introduce some gas like xenon and neon. If you apply some voltage, then discharge takes place, and time hundreds of thousands of tiny cells positioned between the 2 plates of glass. This will happen. Construction. It's very simple. You can see here long electrodes are also sandwiched between the glass plates on both sides. Here inside we can see long electrodes. The address electrodes sit behind the cells along the rear glass plate. The transparent display electrodes. Simply construction is very simple. Just draw the diagram and what are the parts in the diagram. That only we have to explain in construction. Nothing more than that. Working. When voltage is applied, the electrodes gets charged and cause the ionization of the gas resulting in plasma. That means if you apply some voltage in between the electrodes, then the gas will be ionized. It will create plasma. This also includes the collision between the ions and the electrons resulting in the emission of photon light. I already told initially. The interaction between photon and electrons. That's the basic principle. That only will happen here also. To obtain color plasma, the back of each cell has to be coated with the phosphor. Generally, they coated with the phosphor to get better plasma. When the photon light is emitted, they are ultraviolet in nature. These UV rays react with the phosphor to give a colored light. That is the thing. This is about working. Plasma display devices characteristics. Why we need to go for this plasma display devices? There are some characteristics. Plasma displays can be made up to large sizes like 150 inches diagonal. Very high contrast. The plasma display panel has thickness about 2.5 inches. Make the total thickness not more than 4 inches. For a 50-inch display, the power consumption increases from 50 to 400 watts in accordance with images having darker color. Has a lifetime of almost 1 lakh hours. After this period, the brightness of TV reduces to half. These are the some characteristics of plasma display devices. Of course, there are some advantages and disadvantages. If you see the advantages, slimmest of all displays, very high contrast ratio. Contrast ratio will be 1 is to 20 lakhs, and that much of difference will be there. Weightless and is less bulky than GRTs. Like that, there are so many advantages. Here you can see some disadvantage. Cost is much higher compared to other displays. Energy consumption is more. Like that, there are some disadvantages. These displays are not available in smaller sizes than 32 inches. This is about the plasma display devices. Next topic is liquid crystal display. What are these liquid crystals? We know about the crystals, we know about the liquids. What are these liquid crystals? Liquid crystals are the intermediate between the liquid and crystal. Liquids have fluidity and isotropic properties. These liquid crystals have been defined as orientationally ordered liquids, positionally disordered crystals that combine the properties of both the crystalline and the liquid states. That means in this liquid crystals, both the liquids and crystals properties will be combined. The liquid crystals are organic fluids. The individual molecules has a minute cigar-shaped appearance. The molecules will have the preferred orientation or direction called director. There are few types of liquid crystals: pneumatic, cholesteric, smectic. There are three types of liquid crystals. Out of these, first two are most important: pneumatic, cholesteric. Here we can see the diagram of pneumatic and cholesteric phase. See, in the orientation, the difference only will be in orientation and alignment. Types of LCDs, liquid crystal displays.